All right, let's take a look at another example using implicit differentiation. As you see here, right, the x and the y's are mixed on the left and also on the right. So it's easier to just use implicit, because if you do explicit, there's a y square here, there's y here, so it's kind of difficult to isolate y. And that's the main point where we're using implicit differentiation. When explicit does not make sense, then we use implicit. Now, if we want to take the derivative on both sides, okay, so in here it's x squared plus y squared, and on the right side is 6xy. So we're going to use a combo of power rule and product rule, okay? So if we take the derivative of 2x, that's going to give us 2x, right? And if we take the derivative of y squared, it's going to be 2y. But because we want to combine it with the product rule, we're actually multiplying 2y by y prime, right? Okay. And on the left side, want to find the derivative of 6x, let me just use bracket, times just y by itself, right, plus derivative of y times just 6x, right? So on the left we have 2x plus 2y times y prime, and this becomes 6, this becomes just y, plus this itself becomes same y prime, because derivative of y is just y prime. There you go. Now what we're gonna do is, I'm gonna change this to blue to make all the y prime to one side. Okay, I think what I'm gonna do here, I'm gonna move the y prime to one side, bring it all together. All right, so I'm gonna move all the terms that have y prime to the left. So it's gonna give me 2y y prime minus 6x y prime. And I'm gonna move the other term to the right, so it gives me 6y, just 6y minus 2x. Okay, what I'm gonna do is I'm gonna factor out the y prime, just like that, because at the end I just want y prime alone, isolating y prime. So it's kind of like solving literal equation. And what I'm gonna do is I'm gonna divide everything by 2y minus 6x, 2y minus 6x. So now I'm left with just y prime right there, and this is my final answer.